Hello and welcome to your math lesson for today. Today we are reviewing Module 1 and Module 2 so that we are getting ready for the Unit 1 test. Okay, so the Unit 1 test is coming up, so we're going to be reviewing all of Module 1 and 2. So here's an example just quick from Module 1. You can see that they have this written as a fraction 0.81 repeating. Remember, if it has 0.81 repeating on the top, that means we're going to have 9s on the bottom. And because two digits are repeating, we're going to have 2 9s, and we have that number 81. Well, now we can divide both by 9. So 81 divided by 9 is 9, and 99 divided by 9 is 11. So it is the fraction 9 over 11. Example 2 is asking us to solve for x, and when we're looking for example 2 here, we are going to take the square root. Remember, there are two numbers that can go in here. It can be 17 and negative 17, and sometimes we write that plus and minus 17. All right, this one is a cubed root. So what times what times what? So like if I do 5 times 5 times 5, this is 25 times 5, which is 125. Well, that's not enough. So let me try something else. So let me try 10 times 10 times 10. Well, 10 times 10 is 100, and 100 times 10 is 1,000. So what cubed? What number cubed? So the answer is 10. 10 cubed. All right, example 4 here is writing all names that apply. So remember, for these, we're talking about real numbers, and real numbers can either be rational or irrational numbers. And remember, as far as irrational number goes, there's basically two kinds, the square or the pi and square root of a non-perfect square. So something like the square root of 20. All right, a rational number would be something like the square root of 36. So that's a perfect square, and that one's not. Or rational is anything that can be written in the form a over b. So we're talking about fractions and decimals. Okay, then we also have integers. Integers are your positive and negative whole numbers. So like negative 5, negative 3, 5, 15. Then we have our whole numbers. And what whole numbers do is they count with 0, 1, 2, 3, and go on up. Now, this book doesn't always cover it, but there are natural numbers, and these are called your counting numbers. So they start with 1, 2, 3. So 5.4 repeating, that is going to be real. All numbers are real, rational, and that's it. 8 over 4 is the same as 2, so it's going to be natural, whole, integer, rational, and real. Now the square root of 13 is irrational and real. All numbers are real. These are sample problems that are in your book that are already been written out. So here is the homework that I had you actually do. So number 1, find the two square roots. So the two square roots, and we're not going to round to the 0.05, we are going to round to the 10th if they ever need to. So we're only going to round to the 10th. All right, so 16, this is going to be plus and minus 4, because 4 times 4 gives you 16, and negative 4 times negative 4. So this one, when we have a fraction, remember we have to do the top and the bottom. So we have the square root of 4 is 2, and the square root of 25 is 5, and then remember we also have the negative one. The first one's called the principal square root. So 225 is going to be plus and minus 15. 15 times 15 and negative 15 times negative 15. All right, so we have a fraction again. So the square root of 1 is 1, and the square root of 49 is 7, and then we also have negative 1/7. All right, the square root of 10 is going to be, so I'm going to count up here, and 14, we have 15, 16. All right, the square root of 9 is 3, and the square root of 16 is 4. So if we look at that square root of 10, it is between these, and this right here would be the decimal value of 3.5. So the square root of 10, it would be pretty reasonable for us to say that this is going to be 3.1. Now, if you also said 3.2, I would probably let that go too. So 3.1 or 3.2, either answer here would be acceptable. All right, square root of 18. So if you look here, I stopped at 16, but 17 and 18 would be shortly after. And 19, 20, 21, I think I'm going to run out of room, 22, 23, 24, and 25 would be the next perfect square. So right in between, we've got 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4. Right here is basically going to be your 4.5. So this would be about 4.1, 4.2, 4.3, and 4.4. So I would say 18 is right around 4.2. All right, write each decimal as a fraction. So write it as a fraction. Well, these are all repeating. So remember, when it's repeating, what we're going to have on the bottom is going to be a 9. And this only has one digit repeating, the 5. So this is going to be 5 over 9. Number 8, because it's repeating, we have the digits 9 on the bottom, and 6 and 3 are repeating, so 2 digits. So I'm going to put 2 9s on the bottom, and then I have a 63 on top. So I'm going to divide by 9 over 9. So 63 divided by 9 is 7. And 99 divided by 9 is 11. So we have the fraction 7 over 11. All right, and the next one here, we have 214. And on the bottom, we have 999. Okay, now this is 4, 5, 6, 7, so that means 3 doesn't go in there. I think this is simplified, so I think it's 214 over 999. All right, number 10, solve each equation for x. So for this one, for number 10, remember, what number can we put in there to get 361? And this is going to be a 19 and a negative 19. Wow, these are kind of big here. So this one actually comes out to be 12. 12 times 12 times 12 gives you 1,728. Now number 12, remember, when it's a fraction, we're going to take the square root of 49 is 7, and the square root of 121 is 11, and then don't forget the negative one. So it'd be negative 7 over 11. All right, write all that apply. So this is when we're talking about real. Okay, so every single one of these should have the word real written by these, because every single number that we have been dealing with is a real number. Now you have to decide if it's rational or irrational. So I'm looking for pi. None of them are pi. Then the next thing I'm going to look for an irrational is the square root of a non-perfect. So no square root, no square root, square root, but this is perfect. So this is negative 10, and this is not perfect. So this one is irrational. So this one is rational. So all the rest of them have to be rational if they are not going to be irrational. All right, so negative 10, is that also an integer? And the answer is yes, because integers are positive and negative whole numbers. All right, 2/3, that is a fraction, so we can't go any further, so it's just real and rational. And sometimes they do ask us if it is terminating or repeating. So 2/3, if you don't know, you would go ahead and do long division, 3 on the outside, 2 on the inside, put your decimal in there, and 3 doesn't go into 2, but it does go into 20. So 6 times 3 is 18, and now if I subtract, oh, I'm getting a 2 again. So it looks like it's going to be repeating. So this one would be a repeating decimal. All right, 15 divided by 5, well, that comes out to be 3, and that is an integer, and it is whole. And if the option is there, we would also pick natural, because that's what a little kid would say. 1, 2, 3, so they would say a natural number. All right, comparing here. So it looks like I've got some square roots here. So I got to get some decimal values. So if I'm talking about the square root of 4, square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. This is 2 and this is 3. So if we look right here in the middle, this is going to be 2.5. So the square root of 7 is definitely going to be bigger than 2.5. So let's say 2.6 plus 5 is 7.6. Well, the square root of 5 looks like it's going to be about 2.2. So that's going to be 9.2. So it looks like this one is going to be bigger. All right, the square root of 6, well, we have that again here. So that's about 2.4 plus 8. So it looks like I have 10.4 over here. And the square root of 8 is going to be 2.7. So it looks like that's 8.7. So again, it's going to be bigger. All right, the square root of 4 is 2. So I have 2 minus 2, which is 0. And 4 minus something, let's just say 1.7, is going to be something. So that is going to be bigger. So it looks like all of them are bigger. All right, going on here to the last few problems. We have the square root of 81 is 9. Now, 72 divided by 7. So if we're doing long division and it's 72 and a 7, that goes in here 1. And then that's going to be 0. So this is going to be 10 point something and then 8.9. So now they want the least number. Well, the least original number is 8.9. And then my next number is going to be 9, which is the square root of 81. And the biggest number here is 72 over 7, because it's going to be 10 point something. Now let's look at that square root of 7. I just wrote all of those out, so let me just go back here to that square root of 7. And it looks like that square root of 7 is going to be about a 2.6, 2.7. So 2.6, let's say here. Okay, 2.7, something like that. And then 7/3. So what is 7/3? Let's see, 3 goes in there twice. And do I have 1 left over? So this is 2.3 repeating. So let's see, 2.3, 2.5, 2.6. So it looks like they might be just backwards here. So 7/3 is the smallest, then 2.55, and then the biggest number there is the square root of 7, because that's going to be 2.6. All right, so continuing on here, we have a few more that's going to go into Module 2. So it looks like I might have to do a second video for that. So I'm just going to cut it off now, and then we'll do a second video on the Mod 2 review.